Hey everybody, Chris with HVACR Videos. We are here at Heatcraft Refrigeration Products in Stone Mountain, Georgia, and we're about to sit down with the Director of Engineering to talk about AWEF compliance and all the new regulations. All right, I am Chris with HVACR Videos, and I am fortunate enough to be here at the Heatcraft facility in Stone Mountain, Georgia, in the Research and Development Lab. I'm here with Mike
Pennington, Director of Engineering.
Mike Pennington. Now, Mike, in a lab like this, now I walked around and got all kinds of tours today. I have to say it's a very interesting lab. As Director of Engineering, how much influence do you have over what goes on in this lab?
Well, a lot of our product design and development that my group would handle is tested here. So this is the core of what we do to make sure that our equipment does what it's supposed to do. So as we're going through things like AWEF, the annual walk-in energy factor, having to determine that units deliver the capacity that we've designed, that they're doing it with the efficiency that they're supposed to deliver. This is where we do that. So this is a fantastic lab. We're able to test all of the refrigerants that we currently have and those that are coming, even out into the future where we're looking at carbon dioxide and things like that. These guys can tell us in infinite detail what's going on with our products.
So with the AWEF stuff, this is a hot ticket question and gripe from a lot of contractors. What I tend to see as a contractor out in the field, I have my ear to a lot of service technicians, and those service technicians and contractors are constantly, even wholesalers, believe it or not, are complaining about AWEF standards, and they tend to be blaming it on the manufacturers. Okay, and I know that it's not the manufacturers, but enlighten me a little bit on AWEF standards. Okay, my understanding, the AWEF standards apply to walk-in coolers and freezers, 3,000 square feet or less.
Right.
Okay, and essentially, it's kind of like a modern day SEER requirement for refrigeration equipment.
Right.
Okay, now, I mean, is that you guys solely making those changes, or is there other entities that are kind of forcing your hand into making these changes?
Yeah, and that's a great topic of discussion because we hear the same thing you do, right? There a lot of times when people will call us and say, "Hey, I've got a strained situation in the field. What do I do about it? Do I have to have a specific kind of equipment? How do I solve that?" A lot of times that's accompanied with some concerns about, as we're answering those questions, well, why did you do this as a manufacturer? And the truth is, we fully support what the government's doing, right? And the states. So they're trying to minimize the use of energy, trying to improve the climate, all the things that we hear about on the news. We play a heavy role in that, just like HVAC does. So as they're coming up with the requirements for that, we work with them. They ask us, if we do this, what does that mean to you? If we do it this way, what happens? So we work with them to say, hey, if you can give here a little, we can give here a little, and we sort of meet in the middle. Now, what's not negotiable is whether or not we're going to do it. Right. So what is negotiable is how. So when we start designing the equipment, we use a lab like this to say, okay, we've got to balance the performance of the equipment, this new efficiency requirement, along with the cost and the reliability, the application robustness. So you'll hear things like, man, in cold climates, this used to not give me a problem, and now it does. Well, we have to make some changes. So you got to pay attention to how you're installing equipment a little more than you used to.
Yeah.
Right. So you got to read that I&O manual. You got to make sure that you're doing the things that we're telling you to do. And we test the units out here and at other facilities under the Linux umbrella to make sure that they're doing what they're supposed to do through all of those conditions. And then we're very careful to make sure that we prescribe what you've got to do to make it work like that. And then it does. So while we support everything that the government's doing, and we participate heavily, along with other manufacturers, but we're right in the middle of it. We're answering questions, going to interviews and things of that nature to get where we need to be in a way that the manufacturers can handle it. It delivers the products that are actually needed, and the government, state, and federal meet their objectives.
Yeah. Now, a point that I want to cover is, as a contractor out in the field, something that I notice, all manufacturers have to meet the AWEF compliance. I don't know if you covered it already, but annual walk-in energy efficiency factor.
Yeah.
There you go. So all the manufacturers have to meet those those levels and those numbers. But what I tend to notice is every manufacturer seems to meet it a different way. So is it safe to assume that they're more or less giving you a criteria of energy efficiency you have to meet, and you guys are kind of allowed to get to it at any which way you choose, or do they have say in the ways that you get to it?
So that's an excellent question. The way that we are running right now, so after all of these discussions and negotiations, there's a test standard that we all have to follow. It's not negotiable.
Okay.
So when we come out with particularly what's called a net capacity and the annual walk-in energy factor, we've got to have very specific documentation that proves that we did all of our testing, we did all of our checks, and we know what that product is doing. So we know the efficiency and we know that net capacity. So the net capacity is determined by a standard. So when we publish in what DOE calls their CCMS database, that efficiency number and the net capacity, every manufacturer had to come by it the same way, right? So from that respect, it is standard. Now, how we get there from a product design, that's where we depart a little bit, because I've got fantastic lab facilities. Other manufacturers have different kinds of lab facilities, or they use third parties. That has an impact on what you can do, right? So our design approach may be a little different from somebody else's.
Yeah.
Maybe I'm able to buy certain parts better than other people are. Maybe they're able to buy parts better than I can. So we look at that whole picture and decide what the best solution is.
So you brought up a good point, and it's kind of something funny, but following installation and operation manuals, okay, I am guilty of cowboying it sometimes, right? And I've been humbled and learned my lesson, because it's so important that we do follow those manuals. Because what I have learned with your equipment, with other people's equipment, is there's key information in those manuals, and it solves a lot of the problems that we are gonna run into inevitably if we don't follow those manuals. I can remember installing an ice machine at one point and not following the installation operation manual, and then running into a major problem. And so there's all kinds of issues. So I think it is so important. But to be fair, I am as guilty as many other people in that I tend to think it's just a refrigeration system. I'm just gonna wing this, you know? With your guys' equipment, some things that I have learned the hard way is when I'm installing an intelligent evaporator, let's say on a walk-in freezer where we're replacing an existing system, and I'm using the same electrical source that powers the condensing unit that's now powering the evaporator, and we can run into problems in that situation that I've learned the hard way when you see voltage drop and different things, and your low voltage transformer no longer gets the proper voltage. Or I've had people not tap the 208, 240 volt transformers correct, right? And all of this could have been solved had I read the installation operation manual and didn't just try to wing it. So I think it's really important that we explain and we all understand that, especially with new technology in this day and age, it's so important that we follow those manuals and read them. And I think even almost job prep, we need to be doing it before, getting ourselves prepared, you know. And I think that goes a long way too when we're talking about being prepared. I think, and this is a conversation for later, but you know, when we're prepared for technical support calls and different things like that, it's so important to review that information. It
really is. And you make a great point. As we move into a more and more heavily regulated world, because that's the path we're on, right? So if you look back just a few years ago, right, we just really got efficiency regulated in 2020. Well, that means a lot of stuff. And as we move toward these lightly flammable refrigerants and the new safety standards, a lot of things change. So where you come from a world where you've dealt with induction motors, just plain old AC motors that didn't have the electronic commutation to them, different technology. When you go to an electronically commutated motor, if you don't tap the transformer right and you don't have your two phases balanced, that's a problem. The motor can't deal with that. When you're sensing temperatures today and tomorrow, when you're sensing flammable refrigerant concentrations in the air, you need to make sure that stuff is done right. A common thing that we hear, and I'm sure you've run across it, low ambient operation, right? When you're trying to run in low temperatures and we're looking at head pressure, every manufacturer had to do something about that, right? If I don't have to fight as much head pressure, I can raise the efficiency, but I need to be able to change that head pressure when the time comes, right? So the unit still runs as a refrigeration system correctly. So if you read the manuals, it'll tell you how to do that. But you got to do the low ambient kit, right? You've got to do some specific things to make sure that it's going to work. And from our testing, we know that it does work. In addition to that, from guys like you that come back and say, hey, it just didn't used to be this hard. We heard you, right? So we are making some changes. We're saying, okay, we've got to come up with a different balance. We got to come up with a way so that we're closer to the robustness that you used to have where, yeah, I read the manual, but I didn't quite do all of it and it still worked.
Yeah.
We're trying to get back a little closer to that. As those restrictions tighten, though, in that regulatory world, it's going to be harder and harder to do that. So it's good to get in the habit of making sure that you read it all and you did what you needed to do.
I think it's you kind of hit a topic that I wanted to talk a little more in depth about, and that's in the aftermarket side. You know, I'm not going to say that it's easy when you're doing new installations, but if a system's designed properly, it tends to be a little bit easier because it's designed, the condensing unit's designed to work with this evaporator. It's designed for these ambient conditions. But on the aftermarket, on the retrofit side, any supply house we go to today, and I think this is nationwide now, I believe every condensing unit we buy is going to be AWEF compliant pretty much across the board, isn't it?
If there's a label on it that says it's approved for walk-in coolers and freezers, then yes. If that label's not on there, then it's not. But they're both compliant, right? Because you can have a piece of equipment that doesn't meet the minimum AWEF standard because if it's medical or scientific or over 3,000, right? So you can get either one.
Yeah. So the problem that I'm seeing and I'm hearing with my ear to the ground being a technician out in the field is people buying aftermarket condensing units, installing them on existing evaporators, right? The new aftermarket condensing units are AWEF compliant. So they're running lower head pressure. Whether they're doing that through fan cycling, head pressure control valves, but the problems really amplify and present themselves in low ambient conditions when, let's say, they tried to utilize an existing expansion valve, right? And an existing evaporator that's been there for 20 years and they just threw a new condensing unit on it. Well, now, because that expansion valve isn't balanced port and it's not sized correctly in the wintertime, it falls on its face and it doesn't operate properly.
Right.
And again, as technicians, we need to do better. As contractors, we need to do better. And I would even say, go out on a limb and say even manufacturers and wholesalers need to do a better job of educating the entire industry. So I think the responsibility falls all around.
Totally agree.
You know, I've heard things from wholesalers, I've heard things from technicians, and it's like, hey, we all need to do some more research and understand the refrigeration cycle.
Yes.
And I'd say that even growing up in the industry, you know, I'll make a funny term, but I grew up learning beer can cold methods. Is the suction line cold? Is the pressure this much? Then it should be working fine.
Right.
That doesn't fly with modern efficiencies. You know, we have to understand the refrigeration cycle. We have to understand what happens when we lower head pressures and the consequences of, you know, liquid reaction in the system and expansion valve reactions and different things.
Totally agree. Yeah. And you can get, I think, some really good information from Heatcraft, right? And we're very sensitive to that. So we're putting a lot of work into our website and to trying to make sure that we've got the information out there, our mobile app, to make sure that it's easy to get to and that you can share that with other people. And we're kind of trying to be open architecture about it. So that we can share that information. There's other resources like, I'll give a shout out to Emerson, right? With their Emerson 360 webinar series, very well done. It's worth a listen, right? So you can pick up some good information about not just how, you know, systems operate in general, but for today, for tomorrow, what are the changes? What's different? What's coming with these A2Ls? So we can provide a lot of that information. There's other places that you can get it from. So strongly encourage you to look at that because you're absolutely right. It's going to be more and more important. And using those aftermarket parts, pay attention to what you're getting. It matters.
Yeah. It's not showing it, maybe not on this right now, but, you know, we did an R&D tour today and it was very interesting to see how much research goes into a single component before you guys put it out there. And it also further reiterates how important it is to use OEM parts. And I hate to say that because, you know, contractors in general and wholesalers, they want to sell aftermarket parts. And and sometimes you might get lucky and an aftermarket part might work, but staying with OEM means that the testing and all the research and development that you put into that product is going to, you know, be behind that part when we put it in, you know, and it's going to operate the way it's supposed to operate. Yeah. And it's very mind blowing to see all the research you guys have done all over this lab to make sure that those components work.
Man, that is absolutely true. And just to exemplify that, and I think Robert talked about it, or we'll talk about it in his section, vibration analysis, right? When we run a motor in a unit and it vibrates, when it hits those resonant frequencies, which means it kind of goes out of control, right? It doesn't do it all the time, but there are frequencies that have to do with the motor mount, with the sheet metal, with the fan blade. In ECs, it's got to do with the way that the power is delivered to the motor windings. So as we're turning that rotor from an electronic perspective, I've got all the time in the world to watch that rotor turn, even though it might be turning at 800, 900 RPM, right? So those things matter. So when we test it, we sweep the frequencies. And we make sure that whether it's riding on the truck and getting bounced around, or it's running at any frequency under any load, that nothing bad happens, right? And you can imagine there's sort of an infinite number of possibilities of combinations of things that could go wrong. So we're trying to be very careful about that. So if you do go get an aftermarket part and it doesn't perform like what we checked, I honestly don't know what happens, right? We cover as much as we can, give as much safety margin as we can, but there's a lot of stuff available out there to use.
And I don't mean to sound like an infomercial, but as a contractor running a business, I do have to say that using OEM parts really is easier, because it's less stress that I have on my shoulders thinking that my technician, not saying that he can't figure something out, but that he didn't have to go through all this research and make sure that it met this criteria. You know, when I just used the OEM part, I put it in, it clearly was bad, we replace it with the OEM part, and we know that it's going to work.
Yeah, good point. And reliability is one part of that, but in this regulated world, that could affect performance too, right? So if you put in a fan blade that's a different pitch, or a motor that doesn't have the same CFM versus static versus power capabilities, it could be off.
Yeah, and you bring up the pitch on the fan blades. I mean, on the wholesale side and the aftermarket side, that's something that I struggle with, because you go and buy an aftermarket blade, it depends on how the wholesaler bought those blades, and if they bought them in bulk. Sometimes I've seen them come shipped in a giant box with 100 blades just stacked on top of each other, you know, and then you have to use your micrometer to try to kind of figure things out and, you know, get it, and it's still never right, and there's always a vibration.
Oh yeah,
and, you know.
Yep, know exactly what you're talking about.
Frustrating pain point.
Yeah, it's a killer. Yeah, and we do test for that. You know, we recognizing that happens, we do say, okay, here's our standard test, but we know that happens. Go ahead and imbalance that blade. Let's go ahead and sometimes we'll even remove a blade, right, and really pound it. Not necessary to make sure that it survives, but to know where it's going to break, so we at least know where the weak point is, so we can reinforce that. But when we do that, we've got to go back and do all of that resonant stuff again, because it changes the system, right? So we got to make sure that it's still okay.
So with the changing times, obviously, I joke and I say we have a new flavor of refrigerant every month, it seems like. We've got new ones coming out, and, you know, it seems that the trend is going, and obviously we want to protect the environment, okay? You know, on the light commercial side, in the restaurant refrigeration stuff that I do, I'm dealing with a lot of hydrocarbon refrigerants, okay? So how much research are you guys doing? How much are you guys doing with the hydrocarbon refrigerants right now?
Well, we're doing quite a bit. So we've got some products right now, and I think you've seen in the lab where we're testing propane. We're working with carbon dioxide as well. Okay. So as far as on the research end of it, there's a lot of work going on. So and that gets in our research and development group, where they're looking out more in the future. So we're looking at different ways, different systems, different modifications. There's all kinds of intellectual property to navigate through to make sure that we're coming up with systems that we can actually be successful with, that we can get our own intellectual property, be competitive, but deliver the products that are going to work. When you get into those systems, as you're probably aware, not probably, you're definitely aware, they get a little more fickle, right? When you start using carbon dioxide, it's not as naturally robust as a hydrofluorocarbon system might be. So you've got to be a little bit more careful with it. You got to really know what you're doing. And that's probably not going to change, right? So as we move more and more toward that, we'll do more research, and you'll see developments come along that address that, because that's a big deal. So as we start from where we are, as these regulations come about, there'll be a period of time where we're going to probably be using A2Ls, the lightly flammable refrigerants, right? Just because of the chemical construction, they are lightly flammable. There are some under these global warming potential limits that you hear of, like 150 and 300, that are A1s, like a 448, but their capacities are so low for refrigeration, the compressors either have to be duplicated or made so big they just don't make sense. So that's why you're going to see those flammables come in, and a bunch of stuff comes along with it, right? We're going to have to sense leaks. We're going to have mitigation responses. So in some cases, we're going to turn some fans on and just move the air around. We're going to have some isolation valves that isolate parts of the system when a leak event occurs. And in some cases, you're even going to have to exhaust the area. So the amount of charge that you have, the size of the room that it's going in, all of those things are taken into consideration in the calculations about what have you got to do? What have my controls got to do? What have my sensors got to do? You're going to have to protect the refrigerant bearing components that are in the units.
Yeah.
So the safety standards that just now came about to allow the use of those require some of those kinds of changes. So it's going to be an interesting ride. And then as you look toward the future, at some point, you've got, like your state, California, they're already talking about dates in the 2035 or earlier arrangements. It says, look, by this day, you're going to use only hydrocarbons. And now they say that different ways. You've got other states, New York, and other members of like the U.S. Climate Alliance that are talking about the same thing. So some of the dates that they're talking about are pretty soon. Now, whether or not they come about, I don't know, because when we talk about broader use outside of your specific applications, those things aren't necessarily available yet, right? The supply chain, the technologies, et cetera, the costs, those have all got to be taken into consideration before there's a mass movement in that direction.
Now, as you know, today we toured around your R&D lab and had some discussions about the different refrigerants. And when it comes to the hydrocarbons, A3, yeah, when it comes to the A3 flammable refrigerants, how prepared are you guys for the charge limitation increases? You guys have been doing testing on higher charge limitations, and you guys are ready for the inevitable increase in the charge limitations.
Oh, yeah. And as Robert will point out, the propane, isobutane, and propane in particular, it's a great refrigerant, right? It happens to burn really well, but it's a great refrigerant. So when we say it's an A3, there are very low charge limits on that right now. So the biggest ones being discussed at all are 500 and 300 grams here. So if you got an open system, you can go to 500, a closed system, you can go to 300. But nothing really past that. Now, there are plenty of discussions going on to take the charge limits much higher. And I mean a lot higher. So as we look at that, it may very well come about. There's all kinds of headwinds and tailwinds related to that. As you can imagine, you've got everybody from the users of the equipment. You've got people that are concerned about, populated areas, et cetera. You've got the fire safety community, right? So they're all looking at it. But when you talk to the fire safety community, for example, what I hear usually is, I'm not so worried about a fire breaking out in your equipment. It's more the building has caught fire and your equipment is in it. So we need to make sure that everyone's aware of, hey, these are the things we're looking at. In terms of being, scared of it, there are products in your house right now. Your fireplace, your water heater, your propane gas stove, the gas grill. Some people with propane and gas stoves. Those gases are around. They're flammable. They've been around for a long time. Handled properly, there's really no reason to worry about it. Propane's heavier than air, so if it leaks, it's going to settle to the ground. You need to be aware of that, right? It doesn't float off. When we move to the A2Ls, they're not as flammable. That's why they call them lightly or mildly flammable refrigerants. And in my mind, they burn a little bit more like alcohol than they do like gasoline, if you will. Right? It's a striking difference. So while they are lightly flammable, with all the safety precautions that we're taking, as long as you use safe handling practices, I don't think there's a lot to worry about. You need to be concerned. You need to be cautious. But I think you'll find out that a lot of the concerns are maybe not as warranted as some may think they are right now.
And I think that, a lot goes into following proper refrigeration practices. And proper refrigeration practices say that as much as possible, instead of unbrazing components, we cut components out. Now, that's not always practical, but as much as we can, if we cut components out for several different reasons, not just talking about hydrocarbon refrigerants, but releasing moisture if you're cutting out a filter dryer versus unsweating a filter dryer and heating it up. There's so many different things. sweeping a system with nitrogen, purging with nitrogen before you braze, different things, you know, having safety gear near you while you're working. I mean, those are all the basic practices that we've been told to do since the early advent of refrigeration.
Good point.
I think we got away from it with a lot of the very easygoing refrigerants that weren't as susceptible to problems, mineral oil systems and different things where, you know, low efficiency systems where it wasn't right, but maybe people weren't necessarily pulling proper evacuations. And, you know, and yeah, the equipment was kind of forgiving. But again, going back to the point with new technology, with new equipment, with hydrocarbon refrigerants, it's just a matter of following proper installation practices, reading the installation operation manuals, making sure that we're following all the safety procedures. And my personal experience with hydrocarbon refrigerants is I'm kind of blown away with how efficient they are. And when you can look at an identical refrigeration system that 5 years ago had 404A refrigerant or something, and then you look at the new system that has R290 propane, and you realize how much smaller the refrigeration system is, but yet the box even got bigger. The usable refrigerated space got bigger because of the efficiencies of it.
That's right, yeah. And we talked about the capacity, you know, saying, hey, gosh, those A1s, I could use them, but they require a bigger compressor. It's the same thing. So that capacity of the refrigerant, I literally can get more BTU per pound out of this one than I can that one. So absolutely. CO2 the same way, right? It allows you to go it carries some downside too, if you will, a lot higher pressures. Robert talked about some of the things that are important to know and make it a little bit more difficult to use. But that's one of the benefits of it.
Yeah. With the CO2 refrigerants, now I don't do the supermarket, I don't do the heavy industrial, but I'm hearing with my ear to the ground that CO2 is popping up everywhere, right? I mean, supermarkets are converting systems to CO2 systems. New installs are going in with CO2. Where's this going? I mean, CO2 seems to be the game changer.
Yeah, and I think eventually it seems inescapable that's kind of where everything goes. So even with the A2Ls, they are a lot lower global warming potential, but they do carry a little bit more glide than the last, sort of the last vintage, and that will probably continue to increase. That's not all bad, but it is something that's got to be dealt with. But the key thing is it's that global warming potential. So when you think about things like the Montreal Protocol, the Paris Agreement, the Kigali Amendment, you hear those things, those all have objectives down the road that literally mean we're going to continue to decrease. You can watch them stair step down, lots of information on the internet about it. Matter of fact, if you go to the North American Sustainable Refrigeration Council, the NASRAC's website, EPA's website, our website, you can see a lot of information that indicates and becomes real clear that where we are today is going to keep going. So on the efficiency front with the Department of Energy, yes, we're going to keep getting more and more efficient, just like we've done with air conditioning and some other industries. That will happen in refrigeration as well. Global warming potential will continue to decrease. And as laws come about that prompt regulations, those regulations are going to look back at the laws with some kind of a time delay and say, okay, I now have this much time left. What have I got to do? So yeah, I think eventually you're going to wind up seeing a lot of CO2 out there, but we'll see A2Ls, I think, for quite a while.
As a contractor, and I imagine as a manufacturer too, the way the industry is going with all these changes, you know, there's so many people that are upset, they're fighting, you know, and I say it's fair because, you know, we're afraid of change, inevitably. A lot of us are afraid of change, but this isn't stopping anytime soon. And as a technician and as a manufacturer, as long as you're willing to better yourself, as long as you're willing to educate yourself, as long as you're willing to innovate, I think that we're going to be the people that are going to be left, because the industry is changing with or without us. And if we're not here to embrace that change and learn and grow with it, I think we're going to get left out.
Yeah, I think you're right. As a matter of fact, one of the big acts that's in place right now that's driving all this is actually called the American Innovation and Manufacturing Act, or the AIM Act. And so that element of innovation and the spirit of embracing the changes that we need to make, and winning, you know, winning together, right? I've got to listen to you, you got to talk to me,
right?
And we've got to read between the lines, because just like, for example, with a field failure, and I get the report that says broke, okay, number one, I need to recognize there's something wrong.
Right.
I didn't see exactly what it was there, but I need to talk to you about it. And then as I talk to you, you engage me, right? I really do want to know. So same thing with moving toward the future with lower global warming potential refrigerants and with these higher efficiencies. What are the things that we need to do? Because I'll tell you, hey, these are my challenges. Here's the things that I've got to do, but I've got room over here.
Yeah.
I can make this change. What do you need to see?
With technology and, for instance, your guys' intelligence system, things like that, I think are only bettering the industry. And I imagine it's going to better manufacturing innovation too, because I would imagine that whether or not you have the ability to do it now or you're going to do it in the future, you would be able to collect data and report that data back. So that way it gives you more information on a failure point. You have a contractor just saying it's broke, but now you have data to back that it's just broke or this just doesn't work.
Absolutely. Yeah, we capture a lot of that data today, and there's plenty of avenues that we can take in the future to make that even more effective, to be predictive about it, right? To be to figure out that, hey, a problem's about to happen versus it already happened. But even today, I get enough data that I can tell a lot about what transpired before something went south, right? And sometimes it points to the equipment, sometimes it points to the application, but it gives us a good starting point.
So, you know, when you say that you're open to feedback, when you guys grow from feedback, how does a normal contractor like me get a hold of you? How do they get feedback to you?
Yeah, that's a great question. And honestly, we have several channels. So we have ways to get to us on our website, certainly sales representatives. You can call our service department and feedback information that way. When information comes in through any of those channels, we have formal systems that make sure that that information gets to our quality department, that it gets to the product and engineering department, so that we can look at that and say, hey, is there something new here? Do we have our focus in the right place? And are we headed in the right direction? Even when we're doing new product introduction, like the designs that we're doing right now, we involve contractors, customers on our design review teams. So we solicit some of the feedback that way. But yeah, the question is, hey, I've got an issue, call us. Absolutely. Send us a text, send us an email. We are very interested in getting that feedback.
How about contractors in, you know, say someone listens to what I'm saying here and they want to better themselves. How do they learn more about AWEF compliance? How do they learn more about the innovations that you guys are making? How do they better themselves in general?
That's another great question. So there's plenty of websites out there that will direct you to training. Ours is, I think, is a very good one. As a matter of fact, if you look on our website, we've put in an interactive map of the country so that you can literally click on your state, hover over your state, and it will tell you, here's the regulations that are in place right now. Here's the ones that are coming. Here's the refrigerants you can use, the ones that you cannot use. And it'll give you that kind of information. And if you want to go deeper, we'll go as far as going to the Department of Energy with you, going to the EPA with you, or on your behalf to ask questions and things of that nature. Because one thing we can't do, and actually DOE and EPA won't do it either, is make decisions for you. So what we'll do is we'll help you navigate through all of these regulations. And it's not so much that they're complicated. They are. And you know, your state of California, they do a good job of sort of interacting with the manufacturing community, the industry, and developing good, meaningful standards and putting a lot of information out there. But it's still a little bit confusing. It's complicated and it's changing. So in addition to the confusion, it's dynamic. So you need to talk to somebody after you've taken those steps that you talk about to kind of train yourself, get educated, take advantage of our training resources, right? We've got lots of things where we can teach you what's going on.
Got you.
But you've also got to then associate with somebody in some cases that just knows, right?
Right.
So call us. We'll walk you through it. You can talk to me. I'll walk you through it, right? So in a lot of cases, I'll get calls that say, hey, I've got a specific application. What do I have to do? And I'll tell you, I can't make the decision for you because I've always got to say that. But here's what I know. Here's what you can find out, and I'll give you very specific things to look at. So you need some help like that, and we can help you there.
And the website is heatcraftrpd.com, correct?
That's right, yes.
All right, I gotta say, you know, so much information overload for me today, but I do have to thank you very much. All the information you've given me, it is mind-blowing, but at the same time, it's really cool that we have manufacturers that are interested in educating. And the way that you guys have designed your website, the way that you've designed your apps, it does a great job. So thank you very much, Mike. I really appreciate it.
I appreciate you as well. We can't thank you enough for coming out. Every time I have discussions like this, I learn too. So just want to encourage people to have those conversations. We work on this together. We're going to make some great things happen.
This sounds great.
Thanks.